Hello students, welcome to the topic definite integration. Today we will start properties of definite integral. Now, the first property, that is integration of f of x with respect to dx goes from a to b. It is equal to minus of integration goes from b to a f of x with respect to dx. So in first property we can change the limits. A to b becomes minus of b to a. Then second property, that is integration of f of x with respect to dx goes from a to b is equivalent to integration of f of t with respect to dt goes from a to b. So in second property we can change the variable x dx is same as what? T dt, right? Now the third property, that is a integration of f of x with respect to dx goes from a to b is equal to integration of f of x with respect to dx goes from a to c plus integration goes from c to b f of x with respect to dx, where c lies in between a and b. The very important property. Now let us go for the next property. That's the property number 4. Integration of f of x with respect to dx goes from 0 to a is equal to integration of f of a minus x with respect to dx goes from 0 to a. So in the fourth property, that on the right hand side it becomes upper limit minus x. The upper limit is a, so it becomes f of a minus x with respect to dx. This is also very important property. Now let's see the next property. That's the property number 5. Here integration of f of x with respect to dx goes from a to b is equal to integration goes from a to b f of a plus b minus x with respect to dx, that is lower limit plus upper limit minus x, right? Now the property number 6, integration goes from 0 to 2a with respect to dx, correct? That is equal to integration goes from 0 to a f of x with respect to dx plus 0 to a f of 2a minus x with respect to dx. See the second integral part, that is f of 2a minus x. On the left hand side we have the upper limit, that is 2a, so it becomes 0 to a f of 2a minus x with respect to dx. Now there's a one more property, that is property number 7, the very important property, that is integration goes from minus a to a f of x with respect to dx, that is equal to 2 times, that is 2 into 0 to a f of x with respect to dx if the given function f of x is an even function, whereas the value becomes 0 if the given function f of x is an odd function. So total there are 7 properties. Now let's see the proof for the first property, that is the property number 1. Integration of f of x with respect to dx goes from a to b is equal to minus of b to a f of x with respect to dx. Now let us consider integration of f of x with respect to dx, that is indefinite integration. Let us consider that as f of x, capital F of x, right? Now I'm substituting that into the left hand side. Since integration of f of x with respect to dx goes from a to b and we know the integral of that, that is capital F of x, that goes from a to b. So by fundamental principle, substitute upper limit and lower limit. So it will become f of b minus f of a. Let's say the expression 1. Now this is what we want to prove it, correct? In right hand side we have minus of b to a f of x with respect to dx, but integration of f of x is capital F of x as it is. It goes from b to a, right? I'm substituting that. It becomes upper limit minus lower limit, so it will be minus of f of a minus f of b. So again it becomes f of b minus f of a. If I'll put that minus sign inside, that is your expression 2. So from 1 and 2 we can say that integration of f of x with respect to dx goes from a to b is equal to minus of integration goes from b to a f of x with respect to dx. It is proved. So the first property says that we can change the limits a to b can be written as b to a if minus sign is outside, right? Now let's see the proof for the second property, that property number 2. It says that integration of f of x with respect to dx goes from a to b is equivalent to integration of f of t with respect to dt goes from a to b. Now again we'll consider integration of f of x, that is indefinite integral, we'll consider as capital F of x. I'm substituting that into the left hand side. So integration of f of x with respect to dx goes from a to b, and we know the integration of f of x, that is capital F of x. Applying the limit a to b, if I substitute the upper limit and lower limit, it becomes f of b minus f of a. Let's say the expression 1. Now this is what we have to prove it, right? Now see the right hand side. On the right hand side, we'll take that integration of f of t with respect to dt, correct? Since integration of f of x we have considered as capital F of x, so integration of f of t with respect to dt will become capital F of t. That is, I'm substituting into the right hand side. So integration of f of t with respect to dt goes from a to b, becomes capital F of t goes from a to b. Let us substitute the upper limit and lower limit. So again it becomes f of b minus f of a. That is your expression 2. And from 1 and 2 we can see that, is it left hand side and right hand side both are same. So therefore integration of f of x with respect to dx goes from a to b is equal to integration of f of t with respect to dt goes from a to b. It is proved. So the second property says that x dx is same as t dt provided the limits are same. Thank you.